whatever little I know about the concept of meta-analysis. And then all of you know what is systematic review and meta-analysis, right? By this time, what is systematic review and meta-analysis? No, I want more of interaction. I don't want, monologuing. I want polylogging, not even. I want all of you to discuss. I don't want like only just, speaking myself. What is systematic review and meta-analysis? Okay, pooling studies together, collecting evidence. Similar studies. What all you all learned? Just kind of revisiting whatever we have done yesterday. What else? In almost 9 hours, right? Yesterday, 9 hours into 2 sentences.
Did all the systematic review need meta-analysis? Yes or no? No.
Okay. When can we collect? When can we do a systematic review? Or why do you want to do a systematic review? Just your professor told you to do. What do you want to do? As an individual clinician or individual researcher, first ask question. Questioning is the key for any researcher or. Sorry? Okay, because you have like multiple clinical trials, so you don't know which one is truth. Like they might have given same intervention, same comparator, but one study says it works, another study says it doesn't work. What to believe? Whether this study to believe or this study to believe. Correct? If some study published in Lancet is better than some studies published in Indian Journal, is it? It doesn't have to be, right? So it depends on various aspects. So just quickly, can someone says what are the steps? I'm just kind of revisiting all the steps to take you further. What is the first step? First thing is you should have. First is question. You need to ask question, right? Question for summarizing the results, not one question, right? You want to summarize. There should be some evidence, so you want to summarize something. So that's why you are asking that question. Next step. Right? After writing a protocol, you need to register in Prospero. Why? You want to say the world that, okay, this is how I'm going to do. You are not deviating that from your protocol in future aspects. So you are writing your protocol. In your protocol, you need to say everything clearly. From your research question till the way you analyze, till the way you assess risk of bias assessment. And then if you are interested in pooling, someone said, right, pooling. So if you want pooling, then how do you report? Everything should be there in your protocol. So to write that protocol, you need to know all the steps. Next step, you know all the literature search. Where do you search? Don't go to your own library to search. You have to. See, why I'm saying, see, it depends on your question. See, some of the questions we asked about Siddha system of medicine. Heard of Siddha? Ayush? See, there some of the literature is not in your published domain. It will be there all in the old books. Sometimes you need to go back to that to kind of look at what sort of evidence you have. You have to do meta-analysis for that. You want to conduct a systematic review. You need to visit. It depends on what is your question, what you are trying to summarize the evidence for. So once you do a literature search, next step is, right, you are extracting. Directly extract the data, because you said you search in PubMed, Embase, Scopus, you got from 3 databases. So what do you need to do first? Right? First duplicates, because same paper there may be there in PubMed, Embase and Scopus. Remove the duplicates. After removing the duplicates, there are like usually 2 steps. One, screening title and abstracts, and screening selection of full text by screening using your inclusion and exclusion criteria. Correct? So inclusion exclusion criteria, how do you define? I would suggest for each of PICO you define your inclusion and exclusion criteria. For P, I will include population with this. But if the population is this disease, I will not include. I will include all diabetes. But say I will not is your inclusion criteria. But in exclusion criteria, if it is gestational diabetes, if it is diabetes of type 1 diabetes, I will exclude. So then you will be kind of, I mean, for P inclusion, then intervention. What is the drug and dose and dosage of your intervention? Then what would be comparator? You want to go with another drug group comparator versus a placebo comparator or any comparator. So you need to both inclusion exclusion criteria. Then outcome, how that outcome should have been reported in that paper. As what are the different ways of outcome that could have been reported in the papers? Just now morning you heard one. What was the class about? Morning class. I mean the first class just before this. Diagnostic accuracy related outcomes. If you are interested in diagnostic accuracy, or as madam told, if you are looking for clinical trials, what sort of effect measures usually they report? In what ways? Anyhow, we'll see. If you don't know, we'll see those details in the next slides. What is the next step? Extract the data. Once you extract the data, then you assess the quality of that evidence. Is the evidence quality is coming from good paper, bad paper, not based on where it is published or who published it. In terms of actual science, in terms of following the steps, in terms of their methodological rigor, in terms of their reporting style, everything you need to assess them. Once you assess them, if you are interested only in numerical summary, right? It says a treatment A works. Are you fine with that? Or you want to know how much it works than an alternative, right? Always, whenever we say, I mean, as Sir was mentioning, like say drug is efficacious, drug A is efficacious. When can you say some drug A is efficacious? When you say one drug is working for some treatment or for some disease, how one will say that some drug is better? I mean, some drug works for some condition. You say when, I mean, if you don't treat him, then if the natural history should have cured by itself, then see, whenever we say something works, always and always in comparison with an alternative course of action, right? It could be another treatment or it could be even a placebo, right? When we compare to placebo, this works. So it's always a comparative. Efficacy or effectiveness, efficiency is something related to, again, how much bucks you give it to get how much output. That is the efficiency aspect. But if you are interested in that numerical summary, how much in terms of higher, how much times it is higher than the control, how much more numerical value if you are looking for a continuous variable. If you give iron tablets, how it improves anemia. Are you happy with this? If you give iron, it improves anemia. Are you happy with this statement? You say, if I give iron with this, with how much hemoglobin it improves? 1 gram, 2 gram, 3 gram, in how many days? So if you want that numerical summary, then you need to do meta-analysis. Once you do that meta-analysis, the last step is you report that, right? These are all the full steps of, if you are interested in conducting a systematic review and meta-analysis. So what is meta-analysis? What do you understand by, it is not analysis, right? So we are, if you want to have a standard definition, the definition is, it is a statistical analysis that combines or integrates the results of several independent clinical trials or studies considered by the analyst to be combinable. So as the analyst, whoever is doing that analysis, they are sure that those studies could be combinable, even for the one which we are discussing earlier. If you think that those studies are not combinable, you cannot combine. If you are convinced that if I want evidence at this level, if you can combine, it makes meaningful, then you can combine, right? So the usual question comes is, can we do this? Are you sure? How many of you say that you cannot combine these two together in a basket? You cannot? See, it's always, see, in most of the science and research question, if you use it depends, that's the always it suits. It depends on, but depends on what? Our research question. See, if my interest is compare fruits with vegetables, can we combine both of them in a single basket? Yes or no? If my interest is to compare vitamin or whatever mineral value of all the fruits versus all the vegetables, can I all the fruits together, all the vegetable together? Then I can combine. But let's say only apples can be combined together. See, even among apples, if someone says all apples we can put together in a single basket, there are how many types of apples? Kashmir apple to Nagpur, whatever that, different countries apple. Similarly, oranges. See, there are so many varieties. Even if you say only orange, you cannot put all oranges together if your research question is not that. The same thing happens even in clinical condition, right? For same drug, you can combine same drug, like say which condition, any condition of your interest with some treatment. Iron supplementation. Like say, can we put all iron supplementation together? The best answer always is it depends. If you are combining only oral versus intravenous, again only one type of iron with another type of iron. Iron fortified with as a food versus only iron as a separate tablet. It depends on what question you are asking, what you are looking for. So it could be combinable or it could not be combinable. That's why the definition says is if analyst thinks that it is combinable for answering some specific thing, so that it will be useful for some purpose, right? So again, it's again combination of results from two or more separate studies, but you need to always keep in mind, I mean yesterday also some presentations suggesting, can we combine, whether it is appropriate to combine the numerical results of all or perhaps some of the studies. So even though you might have done systematic review, ended up with like say 50 studies, it is not a rule that you need to put all 50 studies for your meta-analysis. Like in the earlier example, the diagnostic studies, if you are not interested in pooling of all diagnostic accuracy results, you can pool separately only for test A, this is my pooled value. For test B, this is my pooled value. It depends on what is your interest and what you think as an analyst, those studies could be combinable. Clear? So then the question comes is, why do you want to combine? Sample size, good. Always you are behind sample size, right? Okay. Why do you want to? What do you mean by sample size? Can you little expand? We have more number of subjects. In one single study, if you combine multiple people, we'll have more subjects. By having more subjects, what will happen? What we are looking at finally? Our effect measure and its precision. So we'll get more precise estimates when we put all the studies together. But it comes at a cost. It comes at various assumptions. But if you are kind of satisfied with those assumptions and things, then it makes sense. First is it improves precisions to estimate the magnitude of either benefit or we are not interested in harm. We are not interested in adverse events. Even though if you are giving treatment, if some drug, how much there are like adverse events reported in multiple studies, if your interest is how much is the summary rate of your adverse events, you can even pool them. Then always if you have more samples, you have more statistical power. Are there any trials which are done to estimate its adverse effects? Which sort of trials? Toxicity studies. Okay, if you want like 1, 2, 3, 4. Okay, fine. I mean that's kind of toxicity studies initially. I mean safety and efficacy. Second type 2, right? Level 2 or level 2 studies. So if you are interested in even pooling, because those which may not be of interest of the individual primary studies, even if trials, if you are interested in pooling something which is not See, whenever they do the trial, they usually calculate sample size for. We calculate sample size in a clinical trial for. Anybody done any clinical trials or any trials? We want to estimate how much it works, right? Simple. I mean, I'm not even asking any statistical thing. How much it works, right? In terms of however it is, usually effect measures are measured in terms of either risk ratio or hazards ratio. If I want to get to show this much risk ratio, how much sample I should have to measure your effect. So usually we calculate our sample size to see how much it works, not for how much adverse effects some drug causes. But even by using this combining, putting together all the studies, you can estimate even the questions which are not answered. Because when you do any study, you don't even only estimate the for the final effect measure. You usually collect all the hemogram or liver function tests, or I mean whole set of tests which may not have sufficient statistical power within a single trial. But when you put together across the studies, you can kind of interpret what could be the effect of this drug on even adverse events. So you can answer the question which are not even posed by those individual studies or individual trials. Then, if your interest is to understand as a data enthusiast how much variability across different studies, that you can kind of get it, or like sort of controversies. Some studies says works and some studies say it doesn't work. What is the truth? So to understand or to settle that controversies because of the conflicting results, so you need to conduct meta-analysis. And if you say some studies works and some studies don't work, by pooling, by doing what Sarah shown, that subgroup analysis, na, for this subgroup of people it may work and for this subgroup of people it may not work. With subgroup of people with this clinical characteristic, by doing that sort of subgroup analysis, you can even say identify study characteristics that are associated with effective outcome, so that though the drug which may not work for the same disease, but the disease with this characteristics it may work, for this maybe mild disease it may work but not in severe disease, or the patients with this disease characteristics it works but with this disease characteristics it doesn't work. So that sort of outcomes also can be done using this meta analysis. So when we say we combine, can we just take an average of effect? How do we usually combine? When we say combine the effect measures, how do we usually combine? Simple our English, I mean like our usually primary school maths level, primary or maximum middle school maths. I'm not even going anywhere, when even I too know that much only. Average, na? Usually, I mean, one rate is saying 2, another saying is 3. When you want to put together, take 2 and 3 average is 2.5. Correct? That is the simplest way, the starting way. If you are taking both of them and taking an average, it means what actually? We are saying both are of same quality. That's why we are putting them together. Correct? That is the understanding, right? Do you think if there are any 2 trials done, both are of same quality? Some may be better, some may be not that better. So which trial would give you more near to the truth? A better study or worse study? Right? So the values coming from better study, you give them more importance. The values coming from worse studies, give less importance. You don't ignore them, give them less importance. That's what we call it as in statistical terms, weightage. So we are weighing studies based on its importance, right? So what do you mean by weighting? Already I kind of explained. So we are kind of weighting studies to kind of give, because larger and more precise studies contribute more to overall estimate. Like if some study done with 1,000 people, some study done with 100 people, same trial with same PICO, which study do you think it gives more realistic effect? Common sense, right? Though with more people would have given more. If both are done with 100 people, but some are done very precisely, some are done ठीक है करना है करने. I mean like as a, I don't want to underestimate like, but as a your MD or DM thesis, one has done as a full detailed thesis. I mean as a research work. Which one would have been taken maximum efforts in terms of minimizing biases? You're sure? as a trial done by your professor versus for your MD thesis you have done a trial? Which one? Which one?
Then
I want to hear.
combining and business. Then you are combining and business.
I,
Know that.
ideally, you should not. But in case, I mean, it's usually believed that someone who has more experience, so they would have taken more care in terms of limiting all the possible biases. So your estimate would be more precise. How do you decide precision? Precision we are always saying in terms of measure of. Yesterday they would have introduced, right? Measure of, how do you usually measure anything? Measure of central tendency, measure of dispersions. So what are the measures of dispersions you know of? Even before standard deviation? Measures of, okay, range, interquartile range, okay. Anything else? Before standard error, before standard deviation, variance. What do you mean by variance? You have like set of data, I mean 10 observations, you have a mean value, right? How much each of the value is moving away from your mean, individual value, that is your variance. If you see the formula, that's what it's actually doing, right? If you put all your like 10 observations, if you take average, that is the central value. Then for each 10 value, how much it is away from the mean value is your, and then sum it up, that is your variance, right? And take a square root of it, it becomes standard deviation. Then divided by your sample size, it becomes standard error. That's all. You are all measuring how much your data is dispersed. So, I mean, ensuring accuracy and precision. I mean, if the more precise studies, if precision means if you're usually measured in various ways. I think yesterday introduced about 95% confidence interval, right? All of you are getting, or it's too much of statistics? If it's too much, then I'll tone down.
We have already rated them like yesterday with these.
ठीक है. So when you say a study is more precise, with wide 95% confidence interval or small narrow confidence interval, right? So by pooling, I mean larger and more precise studies, I mean you can pool by giving a differential weightage based on its precision in terms of 95% CI or its sample size usually. And again, we can say studies with different sample size, design and methodological quality, you can balance that weightage. I mean that's what I'm kind of saying, how much weightage you give considering all these aspects to account for variability or minimizing the biases introduced in various aspects, as well as enhancing the statistical power, I mean because you have larger sample size. So you want to give more weight to which sort of studies? More precise studies or less precise studies? More precise studies with more sample size. So you usually give, but usually these are the two common ways of weightage. If you have more study population, you give more weight to that study. If you have fewer population, you give less weight to that study. If your variance is more, you give clear, right? They are going opposite direction, variance and sample size. And weight is usually closely related with the width of the study, I mean confidence interval. Usually that means wider the confidence interval, less precise. Narrower the confidence interval, I think people are kind of losing, so then I'll not too much focus on. Then the next question comes is, when can we do a meta-analysis? When can we do? When can we do? Studies are there, and as analyst, you think they are combinable based on this PICO. If all the things they appear to be combinable, then you combine. If you think they are not combinable, then don't combine, right? When more than one study, if you have like only one study, can you combine? So at least you need to have two studies to combine. And there should be no, I mean, it's again kind of reiteration of PICO, so there should be no difference in those individual studies. Then outcome has to be measured in, I'm not saying same, I'm saying here, so because you have some statistical measures to kind of handle with or play around with, so that comes with its own costs. I mean, costs not in terms of money, but in terms of limitations and assumptions. But there are some methods for some sort of, I mean, if the outcomes are measured it in different ways. And last but most important, when the individual papers provide those data, then only you can pool. If the papers don't provide the data, as just we are discussing, if the papers are not providing your 2 by 2 table sort of information, can you calculate sensitivity and specificity? The past example, you cannot, right? So you need to have more data that has to be reported in the papers. So then the next step is, what are the steps of conducting? What do you think logically the steps of meta-analysis for combining two things? You have extracted, I mean, till now you framed a research question, you, I mean, searched, you selected studies, even you extracted the data, then if you throw something into it, it throws something back you out, you just believe whatever it throws, right? So as humans, I mean, before even AI captures all our work, at least give a thinking that, I mean, we should be altering that what we want to know from those systems, right? The first step is, first you estimate what is that effect measure for each of the study. Even if the in primary studies, even if they have not even reported the effect measure, but they would have given the sufficient data to calculate, even ourselves we can calculate, right? If they have given how many of them, what is the total population, your intervention and comparator, how many got the effect and how many not got the effect, can you calculate? Same PICO, right? In a treatment arm there are 100 people, 20 people improved, and in control arm 100 people, 10 people improved. That's only they have given. Can you calculate risk ratio? Calculate or not? Risk of getting that event. What is risk ratio? It is risk of getting event in intervention divided by risk of getting that event in control arm, right? Risk is probability. I mean, what is the, how many people are improving? 20 out of 100 is improving. Here 10 out of 100. Take 20 out of 100 divided by 10 out of 100. It is 20 by 10. So it is 2 times. The risk ratio is 2. So that is your intervention 2 times getting better than your control arm. That's all your RR value is saying, right? Even we have calculation for that. So the first stage is you calculate such effect measure for your all individual studies. The next step is put them all together with a weighted summary. That is the second step. That is the second stage of it. But in the second stage, you're not simply averaging, you're averaging by after weighing those studies depending upon its importance. Usually we do by its sample size or the participant sample size. Then if you ask me what are all the different types of meta-analysis, and also please let me know when I need to stop, so I'll be like kind of keep on continuing. So stop me whenever you want to stop. So then there are like different types of meta-analysis available. The usual, most commonly used one is this classic meta-analysis, there where you have both fixed effect pooling and random effects meta-analysis. What do you usually, I mean, don't, if you understand the major concept, that should be more than sufficient. If you think all studies are more or less kind of measure the effect in the same way, right? Then you think all the studies are almost same. I'm not saying similar here, almost same. It means that there is no differences between studies. The other term we use for in statistical is heterogeneity. Heard of this term heterogeneity? Right? There is no heterogeneity. That means all studies are homogeneous. So in that studies we use this fixed effect meta-analysis. So it takes care of, I mean, whatever the difference in individual studies is mainly because of sampling variation, not because of two different sampling from two different populations. But in random effects meta-analysis, we take care of both within study as well as between study variations. I think you will, once you see formulas, you will get even more detailed about it. Another way of meta-analysis is, I mean, if it's too much of stats, you please tell me no. Let me know so that I'll kind of tone down. I'll put it only the simplest things as you want. At least if you know these names, then that will be more than sufficient. Another way is network meta-analysis. Like for example, for urinary tract infection, what are all antibiotics you can give? What are all group of antibiotics you can give? Anything else? There are 3 or 4 different group of drugs. If you want to know which one is best, right? See, when you do meta-analysis, you are only comparing with PICO. That means one intervention with one comparator. One trial is saying intervention with one comparator. But you have that trial for all these drugs for the same condition. Then you want to know, but there are like some, like A as compared to B, and another trial has compared B with C, another has compared C with A. If you have this sort of structure, then you can do what we call it as network meta-analysis, so that you can even rank the studies. I mean, rank the effect measure, which intervention is best, then which is next, which is next. So that is network meta-analysis. So it also takes care of both direct effects as well as indirect effects. Then another way, another meta-analysis is what we call it as IPD meta-analysis. In usually meta-analysis, we pull summary measures. But if you have given the line list of all the trials, then you can use that. Then that we call it as individual patient data meta-analysis. So you can even do much more analysis with IPD data than your regular meta-analysis. But for this, we need to have data. Then another approach, it's a sort of approach in the usual method itself, what we call it as cumulative meta-analysis. So if you want to know historically, I mean, if you order some studies historically, if you, how that effect measure is changing across time. Like the usual example which we give for cumulative meta-analysis is, what would be the vitamin D levels is across different latitudes, latitude or longitude, whatever, right? Depending upon sun thing. So the study is done in different, please correct me whether it's latitude or longitude, I always get confused. So with latitude only, right? So different latitudes, how it is changing. If you can kind of adding each one of them and then to see what is the cumulative value. If you want to get the cumulative thing, you can add studies sequentially and see how the things are changing. It could be even done across timelines. Like for example, if another usual example I give is the leading of petrol or the fuels. When deleted, I mean, when was the deleading of petrol happened in India? You know that, right? Earlier, they need to add lead into the fuel. I think it's in 94, so 2004 or something, if I'm not wrong. So after that, lead has not been added. So you can see across the years, the studies done across the year, how that deleading kind of changed. If you have like several population-based surveys across the year, how that has kind of changed. So then you can do that, what we call it as cumulative meta-analysis. Then one example is subgroup meta-analysis. So we can get specific subgroups and then look at, and usually we do subgroup meta-analysis mainly to explore heterogeneity. If there is a heterogeneity when we put all studies together, but what is the reason for that heterogeneity? Whether it's difference in population, difference in intervention, difference in comparator. So put them and combine them within the subgroups. That is for subgroup meta-analysis. Then even more advanced nowadays is what we call it as this Bayesian meta-analysis. It usually approaches using prior distributions. I mean, it even more complex, and if you are interested, you can learn on these aspects as well. The other variants include dose response meta-analysis. Even for the same drug, they would have given a different dosages. How the effects are changing. You can even do this, what we call it as dose response meta-analysis. I'm just introducing this terminology so that you know at least these terminologies exist. Another umbrella review, if you put all the evidence together, not just only the primary evidence as well as previous systematic reviews, everything together, and ask a larger question, then you can answer that using the method called as umbrella review. And we think that meta-analysis we done for quantitative studies only. No, even for those, any social science people here in the audience? Okay, only one person. If someone you are interested, even if you want to synthesize qualitative methods, there are methods for even qualitative aspects as well. I mean, in terms of qualitative studies as well, integrating findings from even qualitative research to interpret and develop newer theories. And even in the COVID period, the one new thing which come up is what we know as leaving meta-analysis. So we kind of, it is always leaving in the sense, leaving here in the sense, whenever the new evidence comes, you add that study and then you update your results. So that's is leaving meta-analysis. So any questions till now?
Sir, in meta-analysis, statistical data of the individual study is compulsory, 100%. We need to have statistical data in every study we are including.
What do you think? What do you think? Some study has not reported any number.
Qualitative meta is said.
I can answer. Qualitative meta synthesis is different. I think my voice is audible, no? No, qualitative meta synthesis is different. It's not, no statistics involved in this. What is the difference between qualitative and quantitative study? Quantitative study, we need number. Qualitative, there is no number. Story, description, content. There you do meta synthesis also. I can show some paper also. We have also qualitative meta synthesis.
नहीं नहीं मेरा अभी पूरा है 95 अभी 20 फ्रेंडली कंप्लीट हुआ है. I can continue till 1
थोड़ा लगा दो
including hands.
हाँ. See, so what happened now? That is also one emerging area and very few researcher you will get doing qualitative. So आपको उसके लिए qualitative research चाहिए और even systematic review चाहिए. All the steps up to data extraction is same. Study selection is same. Okay. So then how you extract the data in qualitative and quantitative is different. Then analysis is different. So don't do that meta term means same as in meta synthesis. You have to suppose anyone have idea on the qualitative research methodology? Please raise your hands. Anyone conducted qualitative research? There what happened in qualitative study, I am interviewing 10 people, I am recording that, transcribing that and taking that transcript for the analysis. But when I do meta synthesis, then I am doing a systematic approach, reviewing all the studies, same PICO, same formula, same things all are doing, then extracting the study. I got 11 number of finite inclusion study using Prisma also. Now I will extract the data, study characteristic data different. Then you use the result section of all included study and synthesize using the qualitative data analysis principle. There you are using transcript from the patient or interview participant. Here you are using the result of the published studies. That is called meta synthesis. Okay, and don't confuse with the, because there is no number. But you need two skill, meta systematic review skill as well as qualitative research understanding. Thank you, sir.
Thank you, sir. I would like to request Dr. Gita ma'am to felicitate Dr. Bhawani sir with the medal. And now we continue our journey to the hands-on sessions of conducting a meta-analysis from scratch along with our other resource persons.
ऐसे ही चलेगा, but as a procedural things. सर आप भी आ जाइए.
A big round of applause for sir.
दोनों एक्सटेंड कर सकते हैं. Thank you. So can we move on?